Good morning, dear students. Today I'm going to tell you about the introduction of states of matter. Before going to start this chapter, dear students, let's understand what topics we are going to study in this particular chapter. As one day I have given you already one example related to when the movie is going to release. Before movie is going to release to public, its preview is launched in the different TV channels, that is called trailer, and by impression of that trailer the people, or I can say the public, is going to attract toward the theater to watch that movie and increase to watch that movie. After getting those 3-hour movie, then the people are giving review on that movie, how is the movie. It is similar case in your study also. So this is the preview of your chapter, okay? And once you understood the preview of chapter, then definitely you will going to take the interest in whole chapter. So all those topic which is going to be studied in this chapter, I'm going to bring in front of you. So please pay focus and just study it, okay? So the name of the chapter we are going to start with the help of this highlighter. I'm going to start. The name of the chapter is Unit 1, Unit 5, States of Matter. Whereas, dear students, you studied about matter. Matter is those that in which we occupy space and have mass. Matter is everything that occupies space and have mass, okay? And basically we have 3 states of matter: solid, liquid and gas. And we studied interconversion of states of matter in junior classes, that solid can change into liquid, liquid can change into gas, gas can change into liquid, and liquid can change into solid again, okay? So there are basically 2 properties when we are going to study about interconversion. There are basically 2 properties that we need to focus in this particular chapter. Number 1, intermolecular force, okay? Intermolecular force is what now? It is the force between 2 molecules. If we are talking about a solid shape, it means that so many elements, so many molecules, so many small particles, they will come closer to each other, they will tightly packed, they will incompressible. These molecules are very strongly holded to each other. That is called intermolecular force, okay? So basically we will study about 3 type of intermolecular force. Or you can see in junior classes you studied that water molecule is liquid. Why? Because some of the particles are loose. Ice is solid, hard. Why? Because particles of water are very close to each other. And water vapor is very free because it has very less intermolecular force, okay? So basically 3 things are there, 3 forces are there. Because of that the intermolecular force is generated. There is London force, dipole force and dipole induced force. We will study one by one in detail these 3 type of force. Second property is that is thermal energy, and in thermal energy we will discuss about the motion of, or thermal energy you can say related to temperature. When the temperature is increased, the motion of particle increase, and due to the motion of particle increase, like in solid the motion is very less, in liquid the motion is more, and gases are very much free. So dear students, let's understand this was all about that we already know, okay? So these all things we know very well. So I'm going to just help you to tell once again the matter we studied. Matter is everything that occupies space and have mass. It have 3 states of matter: solid, liquid, gas, and its interconversion will give us 2 properties: intermolecular force and thermal energy. Now let's understand about the solid, liquid and gas. There are 3 states of matter: solid, liquid and gas. Whereas solid state, gas state and liquid I have written here like this. I have not written solid, liquid, gas. Reason is that in this gaseous state we are going to study in very detail. The gaseous state we are going to study in this chapter very detail. So if we will talk about the interconversion, solid which change into gas, name is sublimation. Where gas is changed into solid, it is called sublimation. You know very well. Then gas change into liquid, it is condensation. Example is rain. When liquid change into gas, it is called evaporation. And when solid change into liquid, it is called melting. And when liquid change into solid, it is called freezing. Okay, all these terms you know very well. In 9th class you studied. Now I just want to relate that what is in this particular chapter, okay? And if I'll tell you, out of solid, liquid all are solid, gas and liquid. We will study about gases and liquid only. Solid we will study in +2 class, that is the state of matter. The name of chapter is the state of matter. Okay, so in this chapter, in this class, I can say we are not going to study about solid state. We will study about gas state and liquid state of this particular chapter. Okay, so gases, there are two type of gases, where you know very well. If we will take atmospheric gas, it is the mixture of many gases: oxygen, nitrogen, carbon dioxide, water, okay, and hydrogen, even argon. But these all gases has classified into two category. Very simple. Ideal gas, the word ideal you need to keep. Ideal मतलब जो सबसे ज़्यादा ideal है. Okay, ideal gas and real gas. Okay, and what is the difference between ideal gas, real gas? That we will do when we are going to study it thoroughly. So ideal gas also those gas which follow all the laws, those gas which follow gas laws at all the temperature and pressure. You know, temperature, pressure and volume are the three factors which is very important to understand the nature of gas. Okay, suppose now on the basis of these gas laws we can classify some of the laws, but ideal gas are what? Which follow gas law at all temperature and pressure, in which Z is equal to 1. Now what is Z? It is compressibility factor. Okay, compressibility factor, and PV is equal to nRT is, it is the formula of ideal gas. Real gas is what now? It follow gas laws at high temperature and low pressure only. It is not following gas law at all temperature. It is following gas law at high temperature and low pressure, in which Z is not equal to 1. It means that compressibility factor is not equal to 1, or you can say PV is not equal to the nRT. Okay, here we will talk about the van der Waals equation. So when we will talk about liquid, so basically in liquid the properties of liquid we are talking, that is vapor pressure, we will talk surface tension, then we will talk viscosity. Okay, so this is basically up to here we studied, in previous slide. Now after this, if we will talk about gas laws, so there are this is the most important part in this chapter, that is gas laws. Okay, so all these gas laws we need to study. Some numericals will come related to these gas laws, some derivation will come related to these gas laws. So first, one by one, first gas law is Boyle's law. First gas law is Boyle's law, which shows out of you. Before going to study this gas law, let me tell you, dear student, you need to keep 4 parameters in your mind: pressure, volume, temperature and number of molecule. Pressure, volume, temperature, number of molecule. These are the 4 parameters which with the change, with one parameter like pressure will change, so it will change the volume and temperature and number of particle also. If suppose volume will change, so it will change the pressure, temperature, and yes, for example I am taking one example. Suppose we are taking example of ice. You know very well ice is solid. Okay, but when we will increase temperature, so what will happen slowly? Now think practically. The water molecule is there inside the ice, which is very closely to each other. Now what will happen? Those water molecule will spread far away. That's why we studied intermolecular force first. Then this water molecule is going to spread all around, and after spreading, it will exert pressure toward the wall, and the ice is going to be slowly melt. After temperature, ice is becoming liquid, you know. So what is happening? The moment temperature increased, the pressure decreased, because the pressure of molecule decreased and volume increased. Volume increased because if ice is a small piece, so you can see from small piece the amount of liquid that will generate. Okay, hope so you understood. You can do this practice. Take out ice from your fridge, then heat it on a tumbler, or you can say on a bowl on the gas. Then slowly you will see the piece of ice is very small, but when it is melting, it is giving more amount of liquid. When it will keep on melting, its pressure is really become very decreased, very less, and volume becoming increased, and it will become a gas and it can flow all over. Okay, so those parameters we are discussing in this particular law. So first I am telling you first law, that is Boyle's law. These all are gas law. Okay, these are all ideal gas law. These are not real gas, these are real gas. Okay, so now first law is Boyle's law, which give relation P is inversely proportional to 1 upon V. P is inversely proportional to 1 upon V. Mean pressure, increase in pressure will decrease the volume. This is the meaning. Increase in pressure will decrease the volume. Okay, volume mean area. Yeah, I can say the space occupied, and pressure is what? The how close and how far. That is, so Charles' law is what now? Here, with the increase in volume, temperature will increase. Yeah, you can say with the increase in temperature, volume will increase. Third is Gay-Lussac law. With the increase in pressure, temperature will increase. Avogadro law, with increase in volume, number of particles will increase. Dalton's law of partial pressure. Here now we will talk about different gases are there in the air. So each gases have different pressure. So we will combine all the sum of all the partial pressure is called Dalton's law of partial pressure. Graham's law of diffusion. Diffusion you know very well. It is T2 upon T1 under root D2 upon D1 is equal to M2 upon M1. Diffusion mean what? Transfer of one part to other part. Kinetic gas equation is one of the formula is also you know very well. If the temperature will increase, the motion will increase. Okay, so kinetic and gas equation we will study in the motion. And if we will talk about real gas, dear students, if we will talk about real gas, so in real gas we have studied this theory. Okay, in real gas we know what is difference between ideal gas, real gas. Ideal gas follow gas law at all type of temperature and pressure, whereas real gas is only follow gas law at high temperature and low pressure. Here we will study about the liquefaction of gas also. Here we will study liquefaction of gas, in which especially van der Waal equation we will study. And van der Waal equation is giving two type of unit van der Waal equation for A and van der Waal equation for B. Van der Waal equation for A and van der Waal equation for B. For van der Waal A, the unit of van der Waal constant is atmosphere. This is atmosphere liter square mole inverse. Atmosphere liter square mole square. Sorry, atmosphere liter square mole square. And for B, it is liter mole inverse. So this is 1 marks question is coming sometime. What is the SI unit of van der Waal A constant and what is unit of van der Waal B constant? And formula that we need to find out, that is P plus AN square upon V square whole bracket V minus NB whole bracket is equal to nRT. These derivation we will do, this derivation and all these derivation we will do when we are going to study the topic in detail. Okay, so till then let's see one small video to help just to understand the concept of this introduction of states of